Introduction to Web Development. Web development encompasses the creation and maintenance of websites and web applications, involving a broad range of tasks and technologies. It is a dynamic field, constantly evolving with new tools, frameworks, and best practices emerging regularly. Understanding the core principles is crucial for anyone looking to build a career in this exciting area. This course will guide you through the fundamental concepts and practical skills required to become a proficient web developer. We will explore both the client-side and server-side aspects of web creation, providing a holistic view of the development process. By the end, you will have a solid foundation to build upon and create your own web projects. The internet has become an indispensable part of modern life, driving the demand for skilled web developers across various industries. From simple static websites to complex e-commerce platforms and interactive web applications, web development plays a pivotal role in digital transformation. This introductory section sets the stage for understanding the vast landscape of web development and its significance in today's technological world. We will touch upon the different roles within web development and the typical workflow involved in bringing a web project to life. Prepare to embark on a journey into the fascinating world of building for the web. How websites work. Understanding how websites function is fundamental to becoming an effective web developer. When you type a URL into your browser, a series of complex interactions occur behind the scenes to deliver the web page to your screen. This process begins with your browser sending a request to a web server, which then processes that request. The server retrieves the necessary files, such as HTML, CSS, and JavaScript, and sends them back to your browser. Your browser then interprets these files, rendering the visual and interactive elements of the website. This client-server model is the backbone of all web communication, enabling seamless interaction between users and web resources. This section will demystify these interactions, providing a clear picture of the underlying mechanisms. The journey of a web page from server to browser involves several key components working in harmony. DNS, Domain Name System, plays a crucial role by translating human-readable domain names into IP addresses, guiding your request to the correct server. Once the server receives the request, it might execute server-side scripts to generate dynamic content before sending the response. The browser then meticulously constructs the page, applying styles and executing scripts to create the final user experience. Caching mechanisms also come into play, storing frequently accessed data to speed up subsequent requests. Grasping this entire flow is essential for debugging and optimizing web applications effectively. Front-end versus back-end. Web development is broadly categorized into front-end and back-end development, each focusing on different aspects of a website. Front-end development, also known as client-side development, deals with everything users directly see and interact with in their web browser. This includes the layout, visual design, interactive elements, and overall user experience. Technologies like HTML, CSS, and JavaScript are the core tools for front-end developers. Their primary goal is to ensure the website is aesthetically pleasing, user-friendly, and responsive across various devices. A well-designed front-end is crucial for engaging users and providing an intuitive interface. Back-end development, or server-side development, focuses on the server, application, and database that power the website from behind the scenes. It handles the logic, data storage, security, and integration with external services. When a user interacts with the front end, the back end processes those requests, retrieves data from databases, performs necessary computations, and sends the appropriate response back to the front end. Popular back-end languages include Python, Node.js, Ruby, PHP, and Java, often coupled with databases like MySQL, PostgreSQL, or MongoDB. Both front-end and back-end are essential for a fully functional web application, working in tandem to deliver a complete user experience. HTML fundamentals. HTML, or Hypertext Markup Language, is the foundational language for creating web pages and defining their structure. It uses a system of tags to mark up different parts of content, indicating their purpose and how they should be displayed by a web browser. Every web page you visit is built using HTML, which provides the skeleton upon which CSS adds styling and JavaScript adds interactivity. Learning HTML is the first crucial step in your web development journey, as it dictates the content and organization of a web page. Without HTML, there would be no content to style or make interactive. It is surprisingly straightforward to learn the basics, making it an excellent starting point for beginners. Mastering HTML ensures you can properly structure any web content. HTML documents are composed of elements which are typically made up of a start tag, content, and an end tag. For example, this is a paragraph, defines a paragraph element. Some elements, like image for images or BR for line breaks, are self-closing and do not require an end tag. Attributes provide additional information about an element, such as src for an image's source or href for a link's destination. Understanding the correct nesting of HTML elements is vital for creating well-formed and accessible web pages. Semantic HTML5 tags like header, nav, article, section, aside, and footer are important for giving meaning to the content, improving accessibility and SEO. These tags help browsers and assistive technologies understand the structure and purpose of different parts of a web page. Cite by HTML structure and semantics. A well-structured HTML document is crucial for both readability and accessibility. Every HTML document typically starts with a declaration, followed by the HTML root element. Inside the HTML element, there are two main sections, HTML and section. The section contains metadata about the page, such as the title displayed in the browser tab, links to style sheets, and script files, which are not directly visible on the page. The section, on the other hand, contains all the visible content of the web page, including text, images, videos, and interactive elements. Organizing your HTML correctly ensures that browsers can parse and render your content efficiently, and that assistive technologies can interpret it meaningfully for users with disabilities. Semantic HTML5 tags provide meaning to the content they enclose, rather than just defining how content should look. For instance, using header for introductory content, nav for navigation links, main for the dominant content, section for self-contained content, article for thematic groupings, and footer for copyright information makes the document structure clear. This semantic clarity is vital for search engine optimization, SEO, as search engines use these tags to understand the context and relevance of your content. More importantly, it improves accessibility for screen readers, allowing users with visual impairments to navigate and understand the web page's structure more easily. Adopting semantic HTML practices is a hallmark of professional web development, leading to more robust and inclusive web experiences. CSS Basics: Styling Web Pages. CSS, or Cascading Style Sheets, is a powerful language used to style the look and feel of web pages. While HTML provides the structure, CSS is responsible for all aspects of visual presentation, including colors, fonts, layout, spacing, and responsiveness. It allows developers to separate content from presentation, making websites easier to maintain, update, and customize. By applying styles through CSS, you can transform a plain HTML document into a visually appealing and engaging user interface. This separation of concerns is a core principle in modern web development, promoting cleaner code and more efficient workflows. Mastering CSS is essential for creating professional and aesthetically pleasing web experiences that capture user attention. There are three main ways to apply CSS to an HTML document: inline styles, internal style sheets, and external style sheets. Inline styles are applied directly to individual HTML elements using the style attribute, but are generally discouraged for larger projects due to maintainability issues. Internal style sheets are defined within the HTML tags in the HTML document's X section, affecting only that specific page. External style sheets, linked via the X section tag in the X section, are the most recommended method, as they allow a single CSS file to style multiple HTML pages, promoting consistency and reusability. This modular approach significantly streamlines development and ensures a cohesive visual identity across an entire website. Understanding the cascade and specificity rules is also crucial for predicting how styles will be applied. CSS selectors and properties. CSS selectors are patterns used to select the HTML elements you want to style. They are the fundamental building blocks for applying styles effectively. Common types of selectors include element selectors, e.g. P to select all paragraphs, class selectors, e.g. .myClass to select elements with a specific class attribute, and ID selectors, e.g. #myID, to select a unique element with a specific ID. Understanding how to target specific elements or groups of elements is crucial for precise styling. Combinators and pseudo-classes offer even more granular control, allowing you to select elements based on their relationship to other elements or their state. Mastering selectors is key to writing efficient and maintainable CSS code, preventing unintended style applications and making your style sheets more robust. Once an element is selected, CSS properties are used to define its visual characteristics. A property value pair, example, color blue or font size 16px, specifies a particular style. There are hundreds of CSS properties, covering everything from text formatting, font family, text align, color, background color, color, dimensions, width, height, spacing, margin, padding, and position, display. Each property has a set of valid values that determine its effect. Experimenting with different properties and values is an integral part of learning CSS and achieving desired visual outcomes. Effective use of CSS properties allows for intricate and beautiful designs, bringing your web pages to life with rich visual detail. Combining selectors and properties forms the core of all CSS styling. CSS layouts, Flexbox and Grid. Creating effective and responsive layouts is a cornerstone of modern web design, and CSS Flexbox and Grid are the two most powerful tools for achieving this. Flexbox, or the Flexible Box module, is a one-dimensional layout system designed for distributing space among items in a container and aligning them. It excels at arranging items in a single row or column, making it ideal for navigation bars, component alignment, and distributing items evenly. Flexbox provides a robust way to control the alignment, direction, order, and sizing of items within a container, adapting dynamically to different screen sizes. Understanding Flexbox is crucial for building responsive components and ensuring your content looks good on various devices. CSS Grid layout, often referred to as Grid, is a two-dimensional layout system that allows developers to design complex, responsive web page layouts with rows and columns. Unlike Flexbox, which works along one axis at a time, Grid enables simultaneous control over both horizontal and vertical alignment, making it perfect for overall page structures and intricate component arrangements. With Grid, you can define explicit rows and columns, place items into specific grid areas, and create responsive designs that adapt fluidly to different viewports. Combining the strengths of both Flexbox and Grid allows for unparalleled control over web page layouts, enabling developers to create sophisticated and highly adaptable user interfaces. Many modern websites leverage both systems, using Grid for the macro layout and Flexbox for micro layout within grid areas. Responsive web design. Responsive web design, RWD, is an approach to web development that aims to make web pages render well on a variety of devices and screen sizes, from desktop monitors to tablets and mobile phones. In today's multi-device world, it is no longer sufficient to design for a single screen size. Users access content from countless different devices. RWD ensures that the user experience remains consistent and optimal, regardless of how they are viewing the site. This involves using flexible layouts, fluid images, and media queries to adapt the design based on the viewport characteristics. Implementing responsive design is critical for reaching a wider audience and providing an accessible, user-friendly experience across the entire digital ecosystem. Key techniques in responsive web design include using a flexible grid-based layout, which allows content to resize and rearrange itself based on screen width. Fluid images and media, which scale proportionally, prevent content from overflowing or appearing distorted. Media queries are CSS rules that apply styles only when certain conditions are met, such as a specific screen width or device orientation. This allows developers to create different layouts and styles for different breakpoints, ensuring an optimized experience for each device. Mobile-first design, where development starts with the smallest screen and progressively enhances for larger ones, is a popular and effective strategy for implementing RWD. This approach helps prioritize essential content and performance for mobile users, which is increasingly important given the prevalence of mobile browsing. JavaScript Introduction. JavaScript is a high-level, interpreted programming language that is one of the three core technologies of the World Wide Web, alongside HTML and CSS. It enables interactive and dynamic content on websites, making web pages come alive. Initially developed for client-side scripting to enhance user interfaces, JavaScript has evolved significantly and is now also used for server-side programming, Node.js, mobile apps, and even desktop applications. Its versatility and widespread adoption make it an indispensable skill for any aspiring web developer. Learning JavaScript opens up a vast array of possibilities for creating engaging and functional web experiences. It is the language that powers most of the interactive elements you encounter online, from simple form validations to complex animations and single-page applications. At its core, JavaScript allows you to manipulate the document object model, DOM, which is a programming interface for web documents. This means you can dynamically change the content, structure, and style of a web page after it has been loaded. JavaScript can respond to user actions, fetch data from servers, validate user input, and much more. Its event-driven nature allows for highly interactive applications that react to clicks, hovers, and other user inputs. The language is constantly being updated with new features and syntax through ECMAScript standards, ensuring it remains relevant and powerful. Understanding JavaScript is crucial for building modern, interactive web applications that go beyond static content. JavaScript variables and data types. Variables are fundamental to any programming language, including JavaScript, serving as containers for storing data values. In JavaScript, you declare variables using keywords like var, let, or const. Var has function scope, let has block scope and can be reassigned, while const also has block scope, but cannot be reassigned after its initial declaration, making it ideal for values that should not change. Choosing the appropriate keyword depends on the variable's intended use and scope within your program. Proper variable naming conventions are important for writing clean, readable, and maintainable code. Variables allow you to store information, manipulate it, and reuse it throughout your application, forming the backbone of dynamic program behavior. JavaScript supports several primitive data types that define the kind of value a variable can hold. These include string for text, e.g., hello world, number for numerical values, e.g., 10, 3.14, Boolean for true-false values, null for an intentional absence of any object value, undefined for a variable that has been declared but not yet assigned a value, and symbol for unique identifiers. Additionally, there is the object data type for more complex collections of data, such as arrays and functions. Understanding these data types is crucial for performing operations correctly and avoiding common programming errors. JavaScript is dynamically typed, meaning you don't explicitly declare a variable's type, but its type is determined at runtime based on the value it holds. This flexibility is a powerful feature, but also requires careful handling to ensure type consistency. JavaScript control flow. Control flow statements are essential programming constructs that determine the order in which instructions are executed in a program. They allow developers to create dynamic and intelligent applications that can make decisions and repeat actions based on specific conditions. In JavaScript, common control flow statements include conditional statements like if, else if, and else, which execute different blocks of code depending on whether a condition is true or false. These statements are fundamental for implementing logic and decision-making within your applications. Without control flow, programs would simply execute linearly, lacking the ability to respond to varying inputs or situations. Mastering control flow is crucial for building any non-trivial application. Looping constructs, such as for, while, and do-while loops, enable the repeated execution of a block of code until a certain condition is met. This is incredibly useful for iterating over arrays, processing lists of data, or performing repetitive tasks efficiently. The switch statement provides an alternative to long if-else-if chains when dealing with multiple possible values for a single expression. Understanding how to effectively use these control flow mechanisms is vital for writing efficient, readable, and robust JavaScript code. They are the tools that allow your programs to perform complex operations and respond intelligently to diverse scenarios, making your web applications truly dynamic and interactive. Proper use of control flow can significantly impact performance and maintainability. DOM manipulation with JavaScript. The Document Object Model, DOM, is a programming interface for web documents. It represents the page so that programs can change the document structure, style, and content. The DOM represents the document as nodes and objects, allowing JavaScript to interact with every element on a web page. When a browser loads an HTML document, it creates a DOM tree, where each HTML element, attribute, and text content becomes a node. JavaScript can then access and modify these nodes, enabling dynamic updates to the web page without requiring a full page reload. This capability is at the heart of all interactive web applications, making web pages much more engaging and responsive to user actions. Understanding the DOM is crucial for building dynamic user interfaces. JavaScript provides a rich set of APIs for interacting with the DOM. You can select elements using methods like document_getElementById, document_querySelector, or document_querySelectorAll. Once an element is selected, you can manipulate its properties, such as changing its text content, element text content, modifying its attributes, element set attribute, or altering its styles, element style color. Furthermore, you can create new HTML elements, document create element, append them to the DOM, parent element append child, or remove existing ones, parent element remove child. Event listeners allow JavaScript to react to user interactions like clicks, key presses, or form submissions, triggering DOM manipulations in response. Mastering DOM manipulation is essential for creating interactive forms, dynamic content updates, and engaging user experiences. Asynchronous JavaScript APIs. Asynchronous JavaScript is crucial for building responsive and efficient web applications, especially when dealing with operations that take time, such as fetching data from a server. Traditional synchronous code executes line by line, blocking further execution until a task is complete. Asynchronous operations, however, allow tasks to run in the background without freezing the main thread, ensuring a smooth user experience. This is vital for tasks like making network requests to APIs, reading files, or handling user input. Without asynchronous capabilities, a web page would become unresponsive every time it needed to fetch data, leading to a frustrating user experience. Understanding asynchronous patterns is a hallmark of modern web development. APIs, application programming interfaces, are sets of rules and protocols that allow different software applications to communicate with each other. In web development, client-side JavaScript often interacts with web APIs to fetch or send data to a server. The Fetch API and XML HTTP request are common tools for making HTTP requests. Promises and async await syntax provide more readable and manageable ways to handle asynchronous operations, making it easier to deal with the eventual success or failure of an asynchronous task. Promises represent the eventual completion or failure of an asynchronous operation and its resulting value, while async await offers a more synchronous-looking syntax for working with promises. Mastering these concepts is essential for building dynamic web applications that interact with external data sources and provide a seamless user experience. Introduction to version control, Git. Version control systems, VCS, are indispensable tools for managing changes to source code over time. They track every modification made to a project, allowing developers to revert to previous versions, compare changes, and collaborate effectively without overwriting each other's work. Git is the most widely used distributed version control system, offering unparalleled flexibility and power. It enables developers to maintain a complete history of their project, making it easy to identify when and by whom changes were introduced. For any serious development project, especially in a team environment, using a VCS like Git is not just beneficial, but absolutely essential for maintaining code integrity and streamlining workflows. It provides a safety net, allowing developers to experiment with new features without fear of permanently breaking the existing code base. Git operates by creating a local repository on each developer's machine, which contains the entire project history. This distributed nature means that each developer has a full copy of the codebase, allowing them to work offline and merge changes later. Key concepts in Git include repositories, the project's history, commits, snapshots of changes, branches, independent lines of development, and merging, combining changes from different branches. Platforms like GitHub, GitLab, and Bitbucket provide remote hosting for Git repositories, facilitating team collaboration and code sharing. Learning Git is a fundamental skill that any modern developer, as it underpins collaborative software development practices and ensures efficient project management. It is a tool that dramatically improves productivity and reduces the risk of errors in complex projects. Basic Git commands. To effectively use Git, understanding a few core commands is essential for managing your projects. The git init command initializes a new Git repository in your current directory, turning it into a version-controlled project. Once initialized, git add stages changes, preparing them to be committed. You can also use git add dot to stage all changes in the current directory. The git commit m, your commit message, command then saves the staged changes to the repository's history, along with a descriptive message. These three commands form the basic workflow for tracking changes in a local Git repository. Regularly committing small, logical changes with clear messages is a best practice that makes your project history much easier to navigate and understand. Beyond the basic workflow, other commands are crucial for collaboration and managing branches. Git status shows the current state of your working directory and staging area, indicating which files have been modified or untracked. Git log displays the commit history, allowing you to see past changes. To work with remote repositories, git clone copies an existing remote repository to your local machine. Git push uploads your local commits to the remote repository, while git pull fetches and integrates changes from the remote repository into your local branch. These commands facilitate seamless collaboration and ensure that all team members are working with the most up-to-date version of the codebase. Mastering these fundamental Git commands will significantly enhance your development workflow and collaboration capabilities. Front-end frameworks overview. Front-end frameworks are pre-written JavaScript libraries that provide a structured way to build user interfaces, simplifying and accelerating the development process. They offer reusable components, state management solutions, and optimized rendering techniques, allowing developers to create complex and interactive web applications more efficiently. Instead of writing everything from scratch, frameworks provide a foundation of tools and conventions that promote consistency and maintainability. This modular approach helps manage the complexity of large-scale applications and fosters better collaboration within development teams. Choosing the right framework depends on project requirements, team expertise, and performance considerations. They are indispensable for modern web development, enabling the creation of sophisticated single-page applications, SPAs, and dynamic user experiences. Some of the most popular front-end frameworks include React.js, Angular, and Vue.js. React.js, maintained by Facebook, is a library for building user interfaces. Known for its component-based architecture and virtual DOM for efficient updates, Angular, developed by Google, is a comprehensive framework that offers a complete solution for building large-scale enterprise applications, including features like data binding, routing, and dependency injection. Vue.js is a progressive framework that is often praised for its simplicity, flexibility, and ease of integration into existing projects. Each framework has its own ecosystem, learning curve, and community support. While they differ in approach, all aim to solve similar problems, making front-end development more organized, scalable, and enjoyable. Exploring these frameworks is crucial for staying current with industry best practices and building high-performance web applications. Introduction to React.js. React.js, often simply called React, is a declarative, efficient, and flexible JavaScript library for building user interfaces. Developed and maintained by Facebook, it has become one of the most popular choices for front-end development due to its component-based architecture and efficient rendering capabilities. React allows developers to break down complex UIs into smaller, reusable pieces called components, making development more manageable and scalable. This modular approach promotes code reusability and simplifies the debugging process. React's declarative nature means you describe what you want the UI to look like, and React handles updating the DOM efficiently to match that desired state. This paradigm shift makes UI development more intuitive and less error-prone. A core concept in React is the virtual DOM, which is a lightweight copy of the actual DOM. When the state of a component changes, React first updates the virtual DOM, then efficiently compares it with the previous version to identify only the necessary changes. These minimal changes are then batched and applied to the real DOM, significantly improving performance and making updates faster. React also embraces a unidirectional data flow, making it easier to understand how data changes throughout your application. While React is primarily a UI library, its extensive ecosystem of tools and libraries, such as React Router for navigation and Redux for state management, allows it to be used for building full-fledged single-page applications. Learning React is a highly valuable skill for modern web developers, opening doors to building powerful and scalable web experiences. Building components in React. In React, components are the building blocks of any user interface. They are independent, reusable pieces of code that return HTML or JSX, a syntax extension for JavaScript, to be rendered on the screen. Components can be thought of as custom, self-contained elements that manage their own state and logic. There are two main types of components: functional components and class components. Functional components are simpler JavaScript functions that take properties, as arguments and return JSX. They are generally preferred in modern React development, especially with the introduction of hooks, which allow functional components to manage state and side effects. Class components are ES6 classes that extend React component and have their own state and lifecycle methods. Understanding how to create and use both types of components is fundamental to building React applications. Props, short for properties, are a way to pass data from a parent component to a child component. They are read-only, ensuring a unidirectional data flow and making components predictable. When a parent component renders a child component, it can pass data down as props, which the child component then uses to render its UI. This mechanism allows for flexible and reusable components that can display different data based on the props they receive. State, on the other hand, is data that is managed within a component and can change over time. When a component's state changes, React efficiently re-renders only that component and its children that are affected by the state change. Hooks like useState and useEffect provide powerful ways for functional components to manage state and side effects, making them as capable as class components. Mastering the concepts of props and state is crucial for building dynamic and interactive React applications. State management in React. Managing state effectively is one of the most critical aspects of building complex React applications. As applications grow, the number of components and the data they need to share can become challenging to manage, leading to prop drilling or inconsistent data. State management solutions provide centralized ways to store and update application-wide data, making it accessible to any component that needs it, regardless of its position in the component tree. This approach simplifies data flow, improves predictability, and enhances the maintainability of large applications. Without a robust state management strategy, complex UIs can quickly become difficult to debug and scale. Choosing the right state management pattern is crucial for the long-term health of your React project. Several popular libraries and patterns exist for state management in React. Redux is a predictable state container for JavaScript apps, known for its strict unidirectional data flow and concepts like actions, reducers, and a single store. It provides a centralized place for all application state, making it easier to debug and test. The React Context API, built into React itself, offers a way to pass data through the component tree without having to pass props down manually at every level. While suitable for less complex global state, it can become less performant for frequent updates. For simpler local state, React's useState and useReducer hooks are often sufficient. Understanding these different approaches allows developers to choose the most appropriate solution for their specific application needs, balancing complexity, performance, and maintainability. Effective state management is key to building scalable and robust React applications. Backend development concepts. Backend development focuses on the server-side logic, databases, and APIs that power a web application, making it dynamic and functional. It's the invisible infrastructure that handles data storage, user authentication, business logic, and communication with the front end. Unlike the front end, which is directly interacted with by users, the back end operates behind the scenes, ensuring data integrity, security, and efficient processing of requests. A robust backend is essential for any application that requires data persistence, user accounts, or complex computations. It acts as the brain of the application, processing requests and delivering appropriate responses to the client. Understanding these concepts is crucial for building full-stack applications. Key concepts in backend development include server-side programming languages, e.g. Node.js, Python, Ruby, Java, PHP, which execute code on the server to generate dynamic content or interact with databases. Databases, e.g. SQL databases like PostgreSQL, MySQL, or NoSQL databases like MongoDB, are used to store and retrieve application data. APIs, application programming interfaces, define how different software components should interact, allowing the front end to communicate with the back end. Server architecture, security considerations, and deployment strategies are also vital aspects. Back-end developers are responsible for designing, building, and maintaining these components, ensuring the application is scalable, secure, and performs efficiently. The choice of technologies often depends on the project's specific needs and the development team's expertise. Node.js and Express.js. Node.js is an open-source, cross-platform JavaScript runtime environment that allows developers to execute JavaScript code outside of a web browser. Built on Chrome's V8 JavaScript engine, Node.js enables server-side scripting, allowing JavaScript to be used for back-end development. This JavaScript everywhere paradigm is highly attractive as it allows full-stack developers to use a single language for both front-end and back-end, streamlining development and reducing context switching. Node.js is particularly well-suited for building scalable network applications, such as real-time chat applications and APIs, due to its event-driven, non-blocking I/O model. Its vast ecosystem of modules, managed by NPM, Node Package Manager, provides a rich set of tools and libraries for various development needs. Express.js is a minimal and flexible Node.js web application framework that provides a robust set of features for web and mobile applications. It simplifies the process of building web servers and APIs by offering a layer of abstraction over Node.js's built-in HTTP module. Express.js provides routing, middleware, and template engine integration, making it easier to handle HTTP requests, define API endpoints, and serve dynamic content. It is widely used for building RESTful APIs, single-page applications, and microservices. Together, Node.js and Express.js form a powerful and popular stack for back-end development, enabling developers to quickly build high-performance, scalable, and maintainable server-side applications using JavaScript. The combination is a cornerstone of the MERN and MEAN stacks, which are prevalent in modern web development. Introduction to databases. SQL NoSQL. Databases are organized collections of data crucial for storing, managing, and retrieving information in web applications. They provide a structured way to persist data, ensuring it remains available even after the application closes. Without a database, dynamic web applications that rely on user-generated content, product catalogs, or user profiles would not be possible. Understanding different database types and how to interact with them is a fundamental skill for back-end developers. The choice between various database systems depends heavily on the specific requirements of the application, such as data structure, scalability needs, and performance considerations. Databases are the memory of your web application, holding all the persistent information. There are two primary categories of databases: SQL relational and NoSQL non-relational. SQL databases like MySQL, PostgreSQL, and Oracle store data in structured tables with predefined schemas, using SQL, structured query language, for data manipulation. They are known for their strong consistency, reliability, and suitability for complex queries and transactional data. NoSQL databases, such as MongoDB, Cassandra, and Redis, offer more flexible, schemaless data models. Example: document, key value, graph, column family. They are designed for high scalability, flexibility, and handling large volumes of unstructured or semi-structured data, often favored in modern web applications that require rapid iteration and massive scale. Each type has its strengths and weaknesses, and developers often choose based on the application's data characteristics and scalability demands. Many modern applications use a combination of both, known as polyglot persistence, to leverage the best features of each. RESTful APIs. REST, representational state transfer, is an architectural style for designing networked applications, and RESTful APIs are web services that adhere to this style. They are a fundamental part of modern web development, enabling communication between different software systems, most commonly between a client, front-end, and a server, back-end. RESTful APIs use standard HTTP methods, GET, POST, PUT, DELETE, to perform operations on resources, which are identified by unique URLs. This stateless architecture ensures that each request from a client to a server contains all the necessary information, making the system more scalable and reliable. Understanding RESTful principles is crucial for building interoperable and efficient web services that can be consumed by various clients, including web browsers, mobile apps, and other servers. Key principles of RESTful APIs include using a client-server architecture, where the client and server are separate and independent. Statelessness means that each request from the client to the server must contain all the information needed to understand the request, without relying on any stored session information on the server. Resources are identified by URIs, Uniform Resource Identifiers, and representations of these resources, e.g., JSON or XML, are exchanged between client and server. A uniform interface simplifies interactions, and the system can be layered, allowing for intermediaries like proxies and load balancers. HTOAS, hypermedia as the engine of application state, is an optional but powerful principle that allows clients to navigate the API dynamically through links provided in the responses. Designing and consuming RESTful APIs is a core skill for full-stack developers, enabling the creation of robust and scalable distributed systems. Yes,